Hi guys, so today's question is of medium complexity queens that can attack the king. So you have given a chessboard of 8 into 8. You are given a 2D matrix queen. You are given a 2D matrix queen and the king, which represent the position of the queen in the chessboard. Same for the king. The king is placed at this position, and all the queens are placed in the position given in the queen's 2D array. So you have to find that all the queens and their position which can attack the king. Like queens can. Uh, Navigate in any direction, so you have to see that all the queens which can attack the king, although this queen can attack the king, this can also, but only the first ones which can attack the king. Similarly, diagonal wise this is attacking. Another example we can see here, uh, this queen is attacking, this queen is attacking, this is attacking, this can't attack because this queen is already attacking the king. Similarly, these are null and void. So what you have to do, instead of navigating from the queen, each queen, you have to think in other way. You have to navigate from the king. King upwards, king leftwards, king rightwards, king diagonal wise, king upward diagonal wise, left diagonal wise, below left diagonal wise, and right diagonal wise. And you have to navigate the chessboard and see which is the first queen which is attacking the king, and you have to store in the list of integers. So what happened? I have navigated in all the positions. First, I will create a list of integers and create my chessboard where the queens are placed in the board. Queens are placed in the boards of row and column Q. Row and column Q is the position of the queen. Every queen I will store it in the boards which I have taken in the care. Similarly, in the board, I will store the king's position. After storing, I will navigate in all the position. First, navigating upwards in the board. So, navigating upwards in the board require the row to decrease and column to remain the same. Okay, so the row will decrease and the column will remain the same. That is king of one. That is the row will, because we have to start from the king's position and navigate on all the 8 directions. Okay, now navigating downward will increase the row, and similarly the column will remain the same. If we see, the row will increase and the column will remain the same. And if we find the queen, we will break it and come out of the loop, because we need not to consider the other queens. And also similarly, if I met an queen, so I will store in the list and in the list of integers. Every time I have to initialize it because I can't clear the list, otherwise the array list of integer will be empty. So navigating the board will require column to be increased and row will be the same. Navigating left will require the column to be decreased and row will be the same. Okay, navigating left and right, same condition is given everywhere. So navigating diagonal upwards is quite tricky. So if you navigate diagonal upward wise, so you have to end here where the columns ends. Okay, if the column not where the row ends, because in here if you see, the uh, column is increasing, also the row is decreasing. The column is increasing and the row is decreasing. I have increased the row and the column I have taken in the decreasing direction. Also, if j is greater than the boards of length of 0 minus 1, means if j the column is becomes greater than the last column, then we have to break the loop. Otherwise, it will give array index of bounds. Diagonal upwards left from the king. Diagonal upwards left from the king. Similarly, if we have to give the same condition, and here you can see the column is the column is decreasing. Okay, and the row is increasing. So the column is decreasing and the row is I have taken sorry, the row is also decreasing and the column is also decreasing and the row is also decreasing. Yes, and if j is less than 0, means if j is here, we can't calculate here because the 0 is the first position, so we have to break the loop. Navigating downward right. So navigating the downward right requires the column to be increased and the row will be increased also. Row will be increased in the increasing direction till the last row I board of length minus 1. Similarly, I will j is the start. column is the starting position of the king, and I will increase the column also. And the breaking position is either we found the queen or we reach the end of the column. Our column is if we do the j plus plus and we are here. If we move diagonally till here, suppose queen is not there, then instead of increasing, it will give array index of bounds. If j plus, because if j plus plus increases to 9 or 0 to 7, or we can say 8, so if we don't put this condition, it will give this position of that row and that column which is not even there in the board, so we have to break them. Similarly, navigating downwards left, downward left require the row to be increased and the column to be decreased. Similarly, the column is decreased till till here. Okay, if j is less than 0 means the last column is 0. If it gives minus 1, so we have to break it, and we have to store. Similarly, condition will remain the same. I will store in the array of list.